In this lesson, we're going to look at how to identify perfect square trinomials, and once we recognize them, how we can factor them very easily. So make sure you have your essential question written down, and restart the video when you are ready. Okay, so our perfect square trinomials go along with the rule that we already learned called square of a binomial. So previously we learned how to take a binomial and square it, and we could get a trinomial for the result. And now what we're doing is we're looking at the trinomial and looking how we can recognize that it can factor into square of a binomial. Okay? So let's look at some examples and look at how this works. Okay? So the first thing that has to happen here is your first and your last term, they have to be perfect squares. So you have to have perfect squares there in order for this rule to work. Okay? And so what we would do is, if we have perfect squares right here, we're going to take the square root of each one. Also remember, this has to be adding. Okay? So we're going to take the square root of each one of these. So the square root of n squared would be n. The square root of 36 would be 6. Now because this has a minus sign, then we would put a minus sign right here. But now we've got to double check. We've got to make sure this is really a perfect square trinomial. If it is, then the product of the two square roots times 2 will be negative 12n, which it is. So it does work. And so this trinomial factors to n minus 6 squared. Now some of you may be thinking, oh, it's way easier if we just use the old method. Okay, and that's possible. But I need you to practice today using this rule and writing it as square of a binomial, because that's going to be important to something we're doing in the future. Okay? Let's look at the next one. Let's test to see if it's a perfect square trinomial. So is the first term a perfect square? Yes, it is. Is the last term a perfect square? Yes, it is. Okay, so let's take the square root of each one. So that would be 3x. Square root of 4 would be 2. Because this is the subtraction sign in the middle, I would put a subtraction. Okay, and let's test to see if the middle term works out. So their product is negative 6x times 2 gives me 12x. So yes, this is a perfect square trinomial, and so it factors to 3x minus 2 squared. Okay, let's look at the next one. Do I have perfect squares? Ooh, I hope you're saying no. S is a perfect square, T is a perfect square, but 12 and 3 are not. However, let's look at each term. Is there a greatest common factor that I could divide out? Okay, I hope you're saying yes. The greatest common factor here, stupid autofocus. The greatest common factor here that I could divide out would be a 3. And so if I divide out a 3, that leaves me with 4s squared plus 4st plus t squared. Okay, now do I have perfect squares? We do. Okay, so let's see if we can keep going. So if I take the square root, that gives me 2s. If I take the square root, that gives me t. Their product, this should be plus right here, their product would be 2st times 2. Yep, that gives me 4st. So I have 2s plus t squared, and then don't forget to bring that 3 down, because that common factor we pulled out is one of your factors, and without it, it doesn't work. Okay, let's look at the next one. Okay, do I have perfect squares? I do. The square root of 16y squared is 4y. The square root of 25 is 5. According to this, I should put subtraction. Okay, but is the middle term twice the product? And it is not. Okay, so this is not a perfect square trinomial. Now, that doesn't mean it can't be factored, but it's not a perfect square trinomial, and we can't use the rule that we've learned. Okay? Okay, let's look at the last one. Do I have perfect squares? Okay, I want you to notice I do, but there's a subtraction sign right there. So is this going to be a perfect square trinomial? No, it is not. This is not a perfect square trinomial. Now, if we were going to factor that, let's just think about it for a minute. Number one, I'm seeing that they have a greatest common factor of 4. So the first thing I would do is factor out a 4. Let's see, that would be minus 16, right? It's still not a perfect square trinomial because of the negative sign. So if I wanted to factor this more, we would go through our steps. So let's see, negative 16 and positive 8. Are there any factors of negative 16 that add up to 8? 4 and 4 doesn't work because one of them would have to be negative. 8 and 2 doesn't work. 1 and 16 doesn't work. So I'm pretty much done. So this is as far as that would factor. Notice it's not prime. It is not prime because we were able to pull out a GCF.